I think unlike the last talk, there's only probably 2 ideas in this talk, and they're buried in there somewhere. See if you can find them. Okay, so context. This is the overview. I'm going to give some context. I'm going to talk about what I'm talking about. I'm going to ask if AI ops solves the problem. Spoiler alert, it does not solve the problem yet, so that's okay. You all knew that. Talk about what agents do now, sort of, but that's what the rest of the conference is about, so I'll mostly skip that. And then we'll get to crazy ideas about agents in the future for running our computers for us. Okay, here we go. Are we ready for that? You guys seem like really low energy. No coffee? What the hell happened? I got a single thumbs up from like 200 people. This is terrible. This is a poor showing for all of you, a poor showing. Okay, context. Who am I? I'm Todd. I spent the last 15 or 20 years doing AI in production at a bunch of places like Google and OpenAI and Anthropic. But I don't actually know anything about machine learning. Like, there's a lot of math, and math is hard. You all knew that. I care a lot about the reliability of backend systems and how to think about that. I wrote a book that tries to address this with some friends. I have a very strong recommendation to never write a book, so just put that in the back of your head. True story, I'd been working on this book for like the last year, and I had never printed it out. I printed it out, and I was proofing it, and my daughter came downstairs and said, "Poppy, what's that?" I'm like, "That's the book I've been working on." She said, "You were serious about that?" And it had been a year, and this is like a 17-year-old, so it wasn't like it was, anyway, it's terrible. I'm thrilled that coffee is good for you, and there's no top to how much coffee is good for you. So unless you have high blood pressure or unless your heart starts racing, you should just keep drinking coffee. It prevents cancer, it makes you live longer, preventative for Alzheimer's, so just drink a lot of coffee. Good. This is who I think you are. I just made up an idea of who you are. I actually don't know you, so I just made up an idea of who you are, but that's what we do as humans. We sort of imagine our counterparties, and we decide what they are. So I think you care about AI quality to some extent, especially model quality and monitoring model quality, I think. I think you're either excited or nervous or curious or something. You have some feels about agents, which is why you're here. But I suspect that we're late enough or into the middle enough of the hype cycle that most of you, if you have jobs and try to do anything in life, are spending a fair amount of time trying to disambiguate hype from promise from reality. Like, a lot of this stuff is like, it's gonna solve everything, but not now. It's gonna make your life so much better eventually, right? And all of the, like, and there is a curve, and we're on the curve, but I'm gonna spend a little bit of time talking about like where we might go, but a lot of that is maybe, just like everyone else. Here's the context. We are experiencing an objectively massive regular advancements in model performance. Like the AI labs, you know, Google, OpenAI, Anthropic, DeepSeek, others, they're shipping new models every 2 to 3 months that really are substantially better, in some cases substantially different, but are substantially better than previous models. And I think when we reflect on that, one of the things you can do when you're caught in the middle of a hype cycle is look back farther. So think back not to like 6 months ago, but 4 years ago. 4 years ago isn't that long. I know I'm old and many of you are young, but 4 years ago really isn't that long ago. So think about 4 years ago and what the computer models could do for us then compared to what they can do for us now. And that helps you anchor yourself to say, yes, there's an excessive and ridiculous amount of hype. However, it is clear that these things do real things that they could not do 2 years ago, 18 months ago, 4 years ago, certainly. And so given that, I think it is important to realize, yeah, there's hype, but there is also a substantial amount of value that is trickling in, and it's coming at an increased rate. I think many of you are super pressured to adopt AI, but if you're responsible people, I have, by the way, no evidence to indicate that you're responsible people, but if you're responsible people, some of you are responsible people, then you'll know that you can't just like pick up a model and have it do a thing and hope for the best. And people spend a lot of time on hallucinations, and I think hallucinations are real and they're important, but that's not even the beginnings of the biggest problems of some of these real use cases. Right? And so they're getting better, but how much better they are at real use cases depends upon a proof of concept, depends upon an evaluation standard, depends upon you deciding what you want and testing whether the model can do that. Among the use cases, it is clear that software engineering is a major use case, it doesn't just work. Like vibe coding for real production use cases is in fact fake. But vibe coding for prototypes and vibe coding for tools and vibe coding for data analysis and vibe coding for dashboard development and vibe coding for correlation and assistance in understanding what's happening in your systems, all of that's completely real. And that changes who can do software, how much software we can do, et cetera. But there are other use cases as well. Context, I'm going to say what production engineering or SRE is. If it's oversimplified, that's okay. I've been laughed at before. It doesn't make me feel bad. So SRE is what happens when you ask a software engineer to perform an operations function. So this is Ben Trainor's idea of like how he started this at Google. Thought it would be kind of a niche career. It's turned into a pretty significant force in our industry about how we think about running reliable systems. Many people have many different names for this: platform engineering, production engineering, reliability engineering. Even sometimes when people say DevOps, what they mean is people in a dedicated role making software work more reliably in a set of connected systems. Okay, fine. The basics are there. There's a book. There's a new book coming out. It's got a lizard on it. The lizard is a monitor lizard, which for any of you who know anything about SRE know is funny. I also want to point out, like, this is creepy, but the O'Reilly animal that we got on the book is ants. And that was from before I worked at Anthropic, so that was creepy, right? Like a year and a half before then, they gave me ants. And I don't know, I think that's weird. The world is strange. Okay, so what are some of the elements of SRE? SRE is not like a niche thing. So one of the conceptions that people have about production engineering or site reliability engineering is it's just a thing in a corner. They have some expertise, they do a thing. It doesn't work when that's the case. And of course it doesn't, because in the same way that machine learning and AI need to be integrated across your organization, so does reliability engineering, right? It doesn't work if you're like, you do everything you were going to do anyway, oh, and then sprinkle the reliability dust at the end. Like, much like security, much like machine learning, much like reliability, all of these things have to be integrated into your organization. So integrated, it's broad and includes everything that could cause you pain. So that could mean software quality. It can mean engprod, like CI/CD, the idea of continuous shipping, identifying and fixing bugs. It can also include training, hiring. It can include process work. So all of that is in scope, because any of that could be the actual cause of your problems. SREs are expert. They're opinionated. They are interested in repeated and repeatable processes. They tend to be creative, because the idea is not to make the organization move slowly, not to like slow everything down, but to really focus in on a small number of things that you can do to get the largest reliability gains. And as I said, they have to be culturally and organizationally integrated. Remember some of these. I know you're not going to do it, but I'll tell you, remember these words, and then later I'll remind you what they were, so you actually don't have to remember them. I wrote them on a future slide. This is coming back. Okay, AI ops and production engineering for, man, even before the GenAI revolution, we were awash in AI ops, right? Like, we had a bunch of companies telling us they had solved this, like, production engineering, IT operations, that solved it. As like 4 or 5 or 6 years ago, there's a whole sub-practice at IBM that just does this. It's really interesting. So here's what AI ops is supposed to do for us, some of which it actually does, right? So it's way better on unstructured data. One of the biggest problems with understanding, you're running some software, you're running some service, how's it going? Well, you've got some logs over here. You might have some traces over there. You might have incident reports or retrospectives in files in, like, Google Docs somewhere. You probably have a Slack channel where you talk about problems. So this is what you have. And you want to take a step back and say, like, well, how does this stuff relate to each other? From a traditional software engineering perspective, that is tedious as hell, right? It's so tedious, because you got to match up this thing. You're like, well, which incident was that? So you're doing some stupid, like, fuzzy regex matching to try to find the name of the incident. Then you're going to look for a Slack channel that kind of looks like that incident. I think I found it. Did you find it? Maybe you did, right? GenAI is great at this stuff. So this part, like, this is like the huge value is, I have some data. It's in some formats. Please read it for me. That's amazing. And that is actually probably probably 80% of the value of using GenAI for this kind of IT operations is just in the, I can have messy data and it can help me figure it out. Automating anomaly detection is something it was supposed to do really well. Those of you who are smarter than me know that everybody who says they've got anomaly detection solved is wrong. It's just hard. Like, everybody who says it's easy is wrong. It's really, really hard, because what is an anomaly is hard. It's hard for humans. It's hard for humans who are expert in the domain that they are detecting anomalies in. Like, I remember working at Google, and this is because they're Americans, by the way, but I remember working at Google and they're like, everything is wrong. No, everything wasn't wrong. It was World Cup, and they didn't know what World Cup was, so the traffic shifted, and it was an anomaly because search traffic went down, because everyone everywhere else in the world was watching their television where people were playing football. But like, Americans don't know what football is, and they don't watch it, and then there were just like, the traffic plummeted, which looks like a systems problem. And so even if you are an expert in the domain of the system, anomalies are hard to detect. Natural language interfaces, I think a lot of the data folks, like I think Snowflake has definitely talked about a lot of the data folks, Databricks as well, are saying like, hey, SQL is great, but in fact, people didn't learn SQL. And the people who needed to know SQL, who are like product analysts, product managers, sales folks, like those are people who actually have questions like, how many customers in Ohio who also bought X shopped for but didn't buy Y? You all are nerds. You can write that SQL query, but the salesperson who needs to know that, who needs to talk to marketing about why we're not cross-promoting those two products, doesn't want to learn SQL, and like, definitely the GenAI models do that. So things that work right now, there's a trend here. The things that work in AI apps right now are anomaly detection, but primarily when it's integrated into observability systems. Logs analysis as part of a logging system. Root cause analysis when it's integrated into an existing incident management process. Capacity management, prediction, auto-scaling, but usually when it's integrated into a capacity delivery system like a container management or a VM management solution. So the trend here, which is super clear, is these things work when they are a point solution integrated into another system that already does that. But that was not, in fact, that wasn't what I want. I don't know if that's what you wanted, but that's not what I wanted, right? What I wanted was, could you please make my stuff work better? That would be so cool if you would just fix it, make it go pretty, right? Like, that's what I want to say, make it go pretty and go have a cocktail, right? That sounds great, or a coffee, right? Depending on the time of day. Yeah, so here's like a legitimate prompt that I spent time typing out and thought, like, it was like, just please make my systems work better. Find my service level objectives for every service, identify all the problems with all the systems that are contributing most to me missing those objectives, devise fixes to those problems. If you're confident of those fixes and you don't think it's going to cause a problem, just roll them out for me as well, please. Thanks so much, right? Okay, yeah, it didn't, so this is not what anything does yet. Okay, so that's too bad, but that's kind of where we're heading, and I want to talk a little bit concretely about that. Agents are ultimately how we're going to achieve big chunks of this. Like, I'm sure you all have as well. Like, MCP is really simple. Like, the actual thing it does is almost nothing, but it does everything, right? Like, it is the way, I think like it is going to be, and this is not just because I work at Anthropic and I know those kids and they're really smart. Like, this is going to be the way that people simply and easily integrate models, series of prompts about models, and systems to turn into multi-step enduring agents. The future, like, you all will help invent that. A lot of people will help invent that. But I think like the connectivity is what we didn't quite have, and getting that has been enormous. Okay, so agents now. I actually don't want to talk about this that much. Most of the rest of the conference here is about things that agents can do. I think my TLDR, I'm not an expert on this, is it's early days. Of course it's early days. Like, nobody was like obsessively talking about agents 18 months ago, and now it's all anyone can talk about. That's like, usually that means it's a sign that they're going to do something pretty useful very soon. That's not a sign that like they've solved our problems today, which is fine, So they're moving fast. I think, learn about it, find use cases. This is not really about, I don't want to talk about primarily what agents do. Let me talk, here's the sci-fi portion of the talk. This is purely speculative. Actually, it's all purely speculative. what do I know about anything? The future is hard to predict, and when it arrives, it is unevenly distributed. So this could be wrong, and it also could be right for people who aren't us. So apologies if your life doesn't look like this. What? Just what? Really? Really? I'm going to update Chrome right now. No, delay 1 hour. Gee, look at that. Okay, so let me talk about 3 stages of agents in the future, sort of like easy mode, getting better, and wouldn't that be super cool? Again, purely speculative. Easy mode. I think some of this stuff, like when I say it, you're going to think like, that's not crazy. So alerting, right? Like, and again, all in the context of doing production engineering on existing software that's running as a system. Okay, so alerting. When somebody, a human in this case, gets alerted for a problem, just tell them some stuff you think they should look at. So like right now, how many of you have ever been on call for a service ever? Okay, so you get paged, and first of all, you're always like, you're thinking about something else, whether you're asleep and you're thinking about glorious dreaming, or if you're like doing some other work, but you're always distracted and you're shifting context, and so you're kind of disoriented. And then the next thing that happens is you go like, wait, what's going on? Like you sort of ask yourself, like, what is going on? Is this a real alert? What could be causing it, right? And usually what happens is eventually you find 3 graphs that tell you the story. You're like, oh, what happened was someone did a rollout because here's the deployments graph. And then we started throwing errors because here's the errors graph. And then we tried to shift capacity to solve those errors, but we failed because here's some log line that tells me that, right? But it's going to take you 20 minutes if you're good at the system and you know everything to find that. It'd be cool if you got paged and like the thing was just like, hey, I don't know much about much, but here's 5 graphs and 6 log lines. Like if it's wrong, it doesn't matter, right? You're like, okay, cool, but I was going to look at stupid graphs that were irrelevant anyway, and some of these are. But if any of them is what you should pay attention to, you just save me 20 minutes every single time. And I don't think that's that hard. I think actively monitor alert troubleshooting. So watch other people troubleshoot alerts and then fetch relevant context for that. Absolutely. A lot of the product retrospective, postmortem, my partner's a physician and hates that we use the term postmortem because it's like nobody died, which is not always true, but it's usually true for us, thankfully. And so I've been trying to say retrospective because that implies that nobody died. So just consume, like a lot of systems are starting to do this. Consume all the content and like write me a reasonable retrospective. Any of you who have systems that do this will know, like Incident.io has this, PagerDuty has some portions of this. They're kind of okay. What they're terrible at is impact, and they're actually pretty bad at suggested follow-up action items and frequently don't get the root cause right unless somebody said what the root cause was in the Slack channel where people are trying to manage the thing. So I think those could be much better, but we're headed in the right direction. The key thing that hurts my feelings the most is the impact. Like, you gotta know how bad was this? And usually it's like, well, it was down for 73 minutes. I'm like, well, 73 minutes of 1% of my traffic is not the same thing as 10 minutes of all of my traffic. And there's like, well, this one was 73, so 73 is bigger than 10, so this one's a bigger, no, that's not it. And then postmortem follow-up, deprioritize things, triage them, bubble them up. So you're like, you know what, like there's 73 things you decided to do last week. That was foolish. Last week you was foolish. Overly ambitious. You were never going to do those 73 things, but if you're going to do 5 things today that are going to fix some kind of remediation for outages, what should those 5 things be? Okay, the next stage, change management. So this is sort of middle level difficulty. Assess changes and deploys and block those that are risky, right? So now you're starting to think agents could be in the middle of how we're managing deployments. It could be like, and if you think about that, often, I know systems are complicated and messy, and so sometimes you're doing a deploy that you've never done before, that has risks you've never had before. But if an agent had all of the code, all of the versions of all of the code, all of the alert history, all of the discussions and incidents, and knows what the delta is that you are trying to deploy and how you're trying to deploy it, there's no reason it couldn't say, you're going to cause an outage right now, and I'm pretty sure I could tell you why. The thing is, you're going to deploy this, and it's actually going to clear the cache, and you're going to have insufficient capacity to serve the traffic that you're already serving because you didn't notice that the cache format has changed and the old cache is completely invalid, right? That sounds a little bit like science fiction, but in fact, I think we can kind of see a point where agents might be able to do things like that. So fix the deployment plans and propose changes. Alerting, when you get an alert, identify the actual causes. So now this is next level difficulty. Instead of saying, I don't know much, but here's 5 graphs, say, I actually do know. I think this is this. Like, and get it to the point where you're relatively confident of that. I think that could be super interesting. And then actively and continuously tune alerting systems. Alerting systems, I think like teams that page themselves usually spend like, I don't know, 10 or 15% of their time just trying to page themselves the right amount. Like I was actually late this morning for a meeting where people are like, should we only page ourselves in these cases, but how do we make sure that we don't have false negatives so that we don't have outages that we could have fixed that we didn't alert ourselves on, but we don't want too many pages or we're going to be too tired to do the work to make our system better, and all these people want some Claude and we got to give them the Claude, right? So that was the meeting I was in before I came here, and that happens all the time. So why not just have the computers do that for us? And write new alerts. And then finally, and this is starting to segue into the last glorious section, identify engineering projects that would actually improve the overall performance of the system. So do some introspection on what the system does and how it does that, and say like, you need to unify these 3 components. Like if you have a traffic management system that includes, some auto scaling of resources and some direction load balancing, those are actually together a unified traffic management system. But none of us would write them from scratch together because that's hard to think about and it's weird. But they have emergent properties when they behave in slightly different ways or have slightly different views of the world. So identifying projects like that. Then finally, this is the part that's either scary or wonderful, depending on what part of your career you're in and how lazy you are. I'm old and lazy, so this seems great to me, but if you're not, that maybe seems like they're going to take our jobs here. That's the meme in the world. But start to propose and implement whole systems for us. So one of the things, so as you think about, there's 2 trends that I want people to think about where they might go. One of them is AI systems doing software engineering. Like AI systems are coding assistants and are writing an increasing amount of software. The second is infrastructure as code. The unification of those 2 trends means that there's no reason that at some point in the future, computers can't architect, configure, design, write, and deploy their own compute. Now, like when you say things, like all of this stuff, like when I say like, do any of you doubt that within 100 years computers can't deploy their own compute? I'm positive, not positive, it's, we're weird. So somebody disagrees with that. But most of us think like within 100 years, it's guaranteed. There's no way computers won't be able to do that. Can they do that today? Absolutely not. So we're not talking about possibility, we're really just talking about timeline. Some people think it's next year, some people think it's next month, some people think it's 10 years. But like this is gonna happen. And when it happens, it's great because Terraform is really a pain in the ass to work with and nobody likes it and they don't want to use it, but they have to use it because there's nothing much better, so we're going to use Terraform. And Kubernetes is annoying, right? So like if it was just like, just do the things so that you run. You essentially address the system and say, please make yourself run well, thank you. And that's the level of specificity. That would be great, right? Change management, just consume all proposed changes in sequence and schedule them, whether they're proposed by an AI system or a human. Identify the minimum risk way to do deployments, to do scheduled upgrades, to build new data centers, to integrate traffic changes, to do network connectivity. And then finally, observability, like design the observability you need. I think many people have observed that we're in a weird middle ground. And I think software is a good place to see this. We're at the hardest part of the human-AI collaboration right now because the models can't do everything for themselves, so they have to do things in a way that are legible and interpretable and interactable by us. But there are some things that get easier if the models get somewhat better. So take the example of software engineering. The models have to write software with good variable names. They do not need good variable names. It's not important for the models to have descriptive variable names. That's for us. That's for the meatbags, right? Like we are the people who need the good variable names. If the models were actually reliable enough to write and manage their own software, then the task gets easier for them in some sense. And there's a whole set of tasks that are like that with systems engineering as well. So is this a plausible future? Like, I think, like, I would make the case, I think this is most of these ideas are obvious. Like, I am not a creative, intelligent person. These are just like fairly obvious ideas. So none of this should have been surprising to you other than that it's in one place and they gave me time to talk about it. That should surprise you. But I think like these systems are not just plausible, but more or less guaranteed. And the question is like, when are we going to see this level of innovation in the systems engineering and production engineering space? And I think it'll come over time and it'll come in fits and starts. And some of it won't work very well at first. And I suspect, and I'll say this now, like I suspect that many people will roll out versions of this incautiously and too early, and it will cause big problems in the same way people vibe coding and launching apps to the internet launched insecure apps that, of course they did. Like that was painfully obvious that was gonna happen. It will happen in this space as well. Don't worry about that too much. Just don't be one of those people and identify the concrete use cases where this really can help you make your stuff better. So that's all I got. Thank you.